Let's now try to solve this sample problem at hand. Determine the nominal compressive strength Pn for the section given in example from the previous example that we have solved. If E is equal to 20 inches. Okay. So same section pa rin yung given natin as the previous problem. We still have a 14 inches by 22 inches section with reinforcements. Meron kang 4 number 9 on both sides. So, you can easily see na symmetrical naman yung section natin. Therefore, yung plastic centroids yan, basically, nasa gitna lang, 11 inches. Kasi 20 to 12. So, nasa gitna lang malamang yung plastic centroid niya, 11 inches from either edge. Okay? Ngayon, we are given a specific eccentricity which is equal to 20 inches. So, kung 11 inches to, most probably, yung load Pn will be applied 9 inches from the edge. Okay? To have a total of 20. Kasi nga yun yung eccentricity. Okay? So, itong distance na to, from this point up to this point, yan yung tinatawag natin na eccentricity, which is equal to 20 inches. We are given a specific eccentricity. Okay? So, dyan daw natin i-apply yung load Pn. Okay? So, given that condition daw, na dyan natin i-apply yung load Pn. The question asks for the value of Pn. Okay? Yun lang yung given. Yun lang yung given natin sa tanong. Ngayon, with that given eccentricity, we actually don't know ano ba yung magiging itsura ng strain diagram. Okay? Hindi natin alam kung ano yung magiging actual na itsura ng strain diagram. Hindi natin alam kung yung tension still will yield or even yung compression still. Hindi natin alam kung mag-yield ba. So, paano natin malalaman? We have to compute for A. Yun yung main goal natin. Na we have to compute for A. Okay? Using the equations of equilibrium tsaka yung equations of equilibrium na summation forces tsaka movement. Okay? But the problem there is, paano natin malalaman kung ano pa, tension failure ba siya or compression failure or what? Okay? Kasi, mahirap kasi isolve to na hindi mo alam kung tension failure ba siya or compression failure ba siya. Although, for this particular example, nakalagay naman na tension failure siya. Pero, paano ba natin masasabi na tension failure siya? So, we can use yung binanggit ko kanina as a guide. Okay? Kung naalala nyo yung binanggit ko kanina as a guide, sabi ko doon, if yung given eccentricity is greater than the effective depth, we can assume tension failure. TF na lang lalagay ko. TF. Tension failure. Okay? For this case, ang E natin, 20 inches. Ang effective depth natin, given na sa problem, wala dyan hanggang dito sa tension reinforcement. We can assume na tension reinforcement na lang nasama. It's 19.5 inches. Medyo magkalapit yung value nila, but still, yung eccentricity ay greater than sa 19.5. Therefore, we can assume tension failure muna. Okay? We can assume tension failure. Ibig sabihin lang ng tension failure, yung strain that will act dito sa tension na reinforcement natin is greater than the yield strain. Parang sabihin lang. Okay? Pero assumption lang natin yan. Later on, i-verify lang natin yan. I-verify din natin yan kung tama ba yan or hindi. Okay, that's the first assumption that we will make. Assume TF tension failure. Ibig sabihin lang yan yung tensile strain is greater than or equal sa yield strain. Okay? And to make things simpler, we will also assume that compression still yields. Like what we usually do sa doubling. Assume compression still yields. Okay, to make things simpler as well. Sabihin lang yan, yung strain S prime is greater than or equal sa yield strain as well. Okay. So, if that is the case, therefore, we can say that Fs is just equal to Fy as well as here. Okay? We can assume na yung Fs prime is just equal to Fy as well. Then yung purpose niyan, bakit natin ina-assume muna na nag-yield? To make things simpler. Okay? Kasi pag na-assume na natin yan, we can now focus dito sa diagram na to. Okay? So, yung diagram natin na yan, ang kailangan natin intindihin ng mga forces dyan ay yung PN, yung CS, ulit-ulit na lang yan, CS, CC, tsaka yung T. Okay? So, by equilibrium, we can say that yung PN plus T must be balanced by CS plus CC. Okay? To make things simpler, yung plus T dito, lipat na lang natin dito sa kanan para naka in terms of PN na siya. Okay, so burahin ko na siya dito. And then, substitute natin yung mga corresponding values nila. Okay, yung CS natin, CS is just equal to AS prime times supposedly, so lagay ko muna yung general equation na. It's supposedly Fs prime minus 0.85 Fc prime. And then yung CC, it's supposedly 0.85 Fc prime AB. And then yung T, minus T. Minus T is ASFY, supposedly. Okay? So, yan yung CS, CC, tsaka T, respectively. Okay. Substituting the corresponding values, ang AS prime natin, we have 4 number 9. Ang number 9, alam na natin, sabi na natin yung 1 inches squared yan, yung area. Okay. So, we have 4 times 1 inches squared times Fs prime. Pero since we assume na yung compression still yields, therefore, yung stress doon will be limited to Fy. So, lagay na lang natin dito Fy, which is as given from the previous problem, 60 yon. Hindi na binigay dito ulit, pero kung naalala nyo, 60 yung Fy from the previous problem. 60 minus 0.85 ng Fc prime na hindi na rin binigay, pero kung naalala nyo, that is for KSI. Okay. Plus 0.85 ng 4 times A na nawawala. Wala yung A. Hindi pa natin alam yan, yung hinahanap natin. Times B, ito yung B natin, yung width, 14 inches. Minus AS, yung sa tension reinforcement naman, we have 4 number 9 pa rin, so 4 times 1. Kasi nga 1 inches squared yung area ng isang number 9 na bar, times Fy na 60. Okay? So if we will try to simplify that, we'll just try to simplify that. That will be 4 times 60 minus 0.85 times 4 minus 4 times 60. That will be minus 13.6. Unahin ko na yung constant. Minus 13.6. Tapos 0.85 times 4 times 14. That is 47.68. 47.68. Okay? Yan yung PN natin. Okay, sinimplify ko lang yung equation. You have to take note na in terms of A to, yung term na to. Itong dalawang term dito, constant lang naman yan. Kaya pinagsama ko na sila. Naging minus 13.6. Okay. That is using summation forces pa lang. Summation forces pa lang yung ginamit natin dyan na equation of equilibrium. Ngayon, we can also use yung summation moment. Okay. Taking moments about AS na lang. Parang kanina lang. Moment tayo sa AS. So, lahat ng forces na nakikita nyo, i-moment nyo dito. Yan. So, ang kailangan natin makuha, yung moment arm na to. Moment arm yan. Moment arm na to. Tapos, moment arm na to. Yung sa T, syempre, wala na moment arm yan. Kasi doon lang mag-moment. Okay. So, moment arm ng PN from the figure, it's just E, yung eccentricity, which is this, plus this distance. So, ano ba yung distance na yon? Okay? So, kung yung buong depth ay 22 inches, itong kalahati ay 11 inches. And as given from the figure, this is 2.5. So, 11 minus 2.5, obviously, this is 8.5 as given na rin. Okay? So, yung moment arm ng PN ay ano lang, 20 plus 8.5. So, lagay ko na lang dito, 20 plus 8.5 inches. Yung moment arm ng PN. Okay? Yung CS, ano yung moment arm ng CS? 2.5 daw yung location nito. Tapos ito 22. And ito 19.5 pala to. 19.5 tas ito 2.5. So basically, that will just be 19.5 minus 2.5. Yun lang yung moment arm niya. And lastly, yung CC, that will just be the effective depth, 19.5 minus half nung effective depth. I mean, nung compressive depth. Yung compression na block. Half ng compression block. Okay. So, to clarify things, moment muna natin yung PN sa AS. PN times the moment arm na 20 plus 8.5. So, I hope clear yung pagkuha ng distance. So, nasa figure lang din naman yan. So, clockwise yun, that must be balanced by the counterclockwise moments. So, minus na to. Minus CS times the moment arm na effective depth 19.5 minus 2.5 yung D prime. Minus the counterclockwise moment ng CC with the moment arm equal to the effective depth 19.5 minus half no compression depth, compression block na depth, at is A over 2. So yung sum niyan must be equal to 0. Okay? So gawin lang natin siguro silang in terms of PN. So this will be PN is equal to, lipat lang natin yung mga terms sa kanan, CS times 19.5 minus 2.5, simplify ko na. That is 17. So magiging plus CC 19.5, di ko siya mag-simplify. 19.5 minus A over 2 divided by 20 plus 8.5. Okay. And then, substitute the corresponding values na lang. Ano yung CS natin? CS is just equal to ito. Ito yung CS natin. As I've written a while ago. So, this is our CS. So, that is just 4 times 60 minus 0.8. Or I'll just rewrite it para mas clear. CS 4 times 1 times 60 minus 0.85 times 4 times 17 na moment arm plus CC. CC natin ay 0.85 times 4 times A times 14 times the moment arm ng 19.5 minus A over 2 divided by 20 plus 8.5, 28.5. Okay, that's RPN. And then simplifying further, 4 times 60 minus 0.85 times 4. Tapos times 17. Kasi mag-shift sort tayo dito. 3848.8. Tapos plus, ito na in terms of dito, 0.85 times 4 times 40. 47.6 A times 19.5 minus A over 2. Sana hindi tayo malito dyan. This is A A yan, hindi siya 9. Mukha ng 9 kasi. 19.5 minus A over 2. Divided by 28.5. Okay. So, ito yung equation 1 natin. This is our equation 1, this will be our equation 2. Pareha silang in terms of Pn. So kung i-equate lang natin yan, wait ko siya dito. Hindi ko na siya i-rewrite para hindi umaba. I'll just write it equating 1 and 2. Ma-solve natin CA. Okay? So, equate lang natin yung dalawang equation. 47.6A minus 13.6 is equal to 3848.8 plus 47.6A 19.5 minus A over 2 divided by 28.5 should solve. What will be our A? A will be equal to 7.1. 7.1 each. Okay? Yun yung depth of compression block natin. Okay? So from that A, we can easily solve for Pn. Substitute na lang natin siya either sa equation 1 or sa equation 2. So substitute na lang natin. Substitute to 1. Ang Pn natin will be equal to 47.6 times 7.1 minus 13.6. That will be 324.4 kips. Diba? Okay. At yun yung hinahanap sa tanong. Yun yung PN na yun. So, ang PN natin is 324.4 kips. Pero before we accept that as our final answer, we have to check assumptions first. Check our assumptions. Okay? We have to check our assumptions. And ano yung unang assumption na i-check natin doon? Puro kahit yung sa compression steel na lang muna. Let's try to compute for the compression steel. Okay, so how do we compute for that? We have to know first yung C. And since we know that A is equal to beta 1C, therefore, this is C. C is equal to A 7.1 divided by beta 1 na 0.85. 0.85 yung beta 1 natin. 0.85. 7.1 divided by 0.85. So, ang C natin will be 8.35 inches. Okay. So, computing for strain S, which is just equal to 0.003 times C minus D prime. It's supposed to be C minus D prime over C. So that will be 0.003 times C na 8.35 minus D prime na 2.5 over 8.35. Again, strain S prime will be equal to 8.35 minus 2.5, 8.35. It's 0.0021. Okay. And ang strain Y natin, what is our strain Y? Yung na-compute na natin kanina. Strain Y is just equal to 60 over 29,000. This is just equal to 0.00207. Okay? So since yung strain S prime natin is greater than strain Y, therefore, verified compression steel yields. Okay? So, verified na compression steel yields. Okay. Ngayon, next is yung sa tension naman. Yung sa tension steel. Yung strain S or strain T na tinatawag. Strain T is just equal to 0.003 dt minus C over C. Okay. So that will be 0.003 dt natin ay equivalent lang sa D, 19.5 minus 8.35 over 8.35. Let's check. 0.003 times 19.5 minus 8.35 over 8.35. So that is equal to 0.004, which is greater than strain Y. So therefore, verified then, tension steel yields. Tension steel yields. Okay. Na-verify na rin natin na tension steel yields. So with that, okay na. Okay na. Kasi na-verify naman natin yung mga assumption natin na tension failure siya. Sabihin yung tension steel mo, nag-yield siya. Kita naman natin 0.004. Tapos na-verify na rin natin na yung compression steel, nag-yield din siya. Okay, which is compression steel. Steel. Na-verify na rin natin na compression steel really yielded. Ayun na. Sa pamamagitan ng pag-compute ng strain. So with that, we can now accept the answer that we have computed. So the final answer for this problem is this. Ang PN for this given problem is equal to 324.4 kips. And that PN with the given eccentricity of 20 inches will produce a tension failure similar to this. Okay? Kung medyo pinapahanap pa yung mga ultimate strength, ganyan, you just have to multiply this by phi. Kumpitin nyo lang yung phi base dito sa tensile strain na 0.004. So I think medyo familiar na kayo on how to do that. And then, multiply na lang dito sa PN. Kung hinahanap lang din naman yun, yung VPN or yung PU na natawag. Okay? Kung hinahanap din yung MN, so assume lang natin hinahanap yung MN. Basically, ang MN is equal to PN times E. Yan lang. So, yung PN na to, multiply mo lang dun sa given E na 20 inches. That's it. That's the nominal moment capacity. Hinahanap yung ultimate, multiply mo lang sa phi yan. Compute mo lang yung strain reduction factor with this given strain T. So, most probably, nasa ano to? Nasa transition to kasi 0.004 siya. Diba ang limit natin sa transition from 0.002 to 0.005? So, most probably, nasa transition to. So, most probably, mga less than ano yan? Less than 0.9 yung phi yan. Okay? So, that is the final answer for this problem.